right, in this video, we're going to go over the line of best fit and the correlation coefficient. Go ahead and either pause this video to write these notes down, or you can take a screenshot if you're on a device where you can do so. A scatter plot is a set of data pairs, so you know it'll be points plotted all over the graph, all over the place. Correlation is the tendency of the slope of the scatter plot, The graphs below show a positive correlation and a negative correlation. So positive correlation is when all of your dots are going up from left to right, and negative correlation is when they're going down from left to right. Now, the correlation coefficient is usually represented by the letter R. And you can tell whether the correlation coefficient has a strong correlation, a strong negative correlation, or a strong positive correlation. And the closer it is to the middle or the zero, that's how weak it is. So if R is near 1, the points lie close to a line with a positive slope. If R is near -1, the points lie close to a line with a negative slope. And if R is 0, the points don't lie close to any line. They're just all over the place. And another way to kind of think about it is think of a number line where 0 is in the middle and you're going from -1 to 1. If I was to pick, let's say my decimal is 0.86. Well, where would 0.86 lie? 0.86 will be somewhere close to 1, but over here, not as close to 0. So if it's 0.86, it's going to have a stronger positive correlation simply because it's closer to 1. But if my decimal was like a negative, let's say 0.4. Now, negative 0.4 will be much closer to 0. And so a decimal like that would have more so no correlation at all because it's very close to 0. All right, line of best fit. Line that lies as close as possible to all of the data points, So as you can see in the first graph, that's the line of best fit because it's as close as it can be to most of the points on the scatter plot. Whereas in the second graph, you have points all over the place and the line is nowhere near close to them. So for an example, this is not a line of best fit. The line that was drawn on the graph is not as close to all of the points on the graph. Whereas in this example, it is a line of best fit because it goes through the middle of where most of the points on the graph lie. All right, sometimes you're given a real application problem and they'll give you an equation to represent it as well as your correlation coefficient R. So it says the local ice cream shop wants to see the relationship between the number of weeks after the start of winter and the number of customers. Plot the points, find the equation of the best fit and the correlation coefficient. So I already did all that part. For letter A, it says, what does R mean in this context? So looking at the fact that my R is negative 0.96, and if you think about that on a number line, where 0 is in the middle, you have -1 over here and 1, negative 0.96 is very, 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 very close to -1. Very close. So that means it has a strong negative correlation. Since it has a strong negative correlation, what does that mean in context? Well, since we're talking about ice cream at the ice cream shop during the winter, yeah. After the start of winter, like when it starts to get really, really, really cold, are people buying as much ice cream? Not really. So as you can see, as the number of weeks increases, the amount of customers is decreasing. You see how it's going down? So that's basically what it means. That's a strong negative correlation. As the number of weeks continues to increase, the number of customers is decreasing. It's going down. All right. Now they want us to use this formula to find the estimated number of customers in 3 weeks after winter. So I'm going to plug in 3 right here using this equation. And then when I type everything in my calculator, it gives me 172.5. So that's how many customers there will be after 3 weeks. giving an estimate. And that's